This is a trigonometry lesson on coterminal angles. Coterminal angles are angles that are, well, let's look at a unit circle. On the unit circle, they're a certain angle, and if you want to go one full rotation, either positive or negative, you end up at 360 degrees either in the counterclockwise direction, positive, or 360 degrees in the negative, the clockwise direction, back to the same angle. The terminal side is the end of the angle. 0 degrees is the initial side. If you're in radians, it's the angle plus or minus 2 pi. You can do as many rotations as you want. So you might put times 2 here or times 3. So example of that would be a 53-degree angle, which would be a first quadrant. And the 53-degree angle would have 360 added to it, would give 413. That's exactly the same place on the unit circle as it would be at 53. Subtract 360 and you get negative 307. These are harder angles to recognize. And sometimes when you're doing an angle like 413, you have to break it down into 360, subtract it from this, 413, and get 53. So you'd realize, oh, I'm 53 degrees into the first quadrant. Couldn't tell that with this number 413. Take this negative angle, which would be in the third quadrant. This is clockwise rotation. And so we would add 360, which would give us positive 191, a little over 180 degrees. And if we subtract the 360, we'd get negative 529 degrees. So big difference by adding or subtracting 360. If I'm in radians and I want to find coterminal, I have an angle here, 1.2 radians, which would be still in first quadrant. If I add 2 pi, probably on my calculator I'd use the pi button on this, 2 times pi, or 3.14, and add it together, it would be this many radians. This is not a number we recognize very well. A radian doesn't often have a RAD on the end of it, it just has theta equals. If we want to subtract, go in the negative 2 pi direction. That would give us negative 5.0832, and of course that decimal goes on. And let's see this again. The theta equals 2.7, see there's no degree mark, so that's a radian, would be over here in the second quadrant. And second quadrant, 2 radians would be about right there at 114. So here's what the angle would look like. So we would want to add, since I'm in radians, we would want to add 2 pi, which would give us 8.9832, or subtract 2 pi, which would give you negative 3.5832 radians. Now, if you need to stop at any time, hit the pause button. I have 2 more. One is 4.1 radians. That is a third quadrant. 4 radians is over in here, right around in here. Slightly beyond that is this. We don't want to convert it into degrees. We want to just add 2 pi and subtract 2 pi. And let's go back to this problem, 1.7 pi radians. Now we have 1 pi, which goes over to the 180 axis, and 3/4 more, or 0.75 more. Not exactly a 2 pi rotation. Well, this angle right here is actually my reference angle between these two. So again, to find the coterminal, I'm going to add 2 pi, 3.75 pi radians. Big difference if there's a pi on this rather than without a pi, like over here. This means I take it times 3.14. Now, my unit circle is laid out by 1 pi, 2 pi, so that kind of gives me a reference point. I could subtract 2 pi, and that would give me negative 0.75 pi radians, negative 3/4 pi. So that would be right around in here. I'm sorry, this would be 0.25. That's a mistake. Okay, hope this helps you a little bit on coterminal.